Bismillahirrahmanirrahim. My name is Shiraz Ahmed Siddiqui. I am giving a presentation on the conversion of decimal number to a binary number. So, first of all, we will see the main contents that cover our presentation. So, here are the main contents of our presentation. So, first one is what is a binary number. First of all, we will see about the binary number. What is a binary number? And then what is a decimal number? And then the relationship between them and how we convert decimal into binary number. And last, we will see about the examples how we convert decimal into the binary. So let us discuss these contents in a detailed way. So first of all, we will see what is a binary number. So a binary number is a number that includes 1 and 0. Basically, in a binary number, the two digits are included. First 0, then 1. Then the length of the binary number could be any one. It's include 1, 2, 3, 4, and so on. The following are the example of binary number. The binary number of 0 is 1 0 1 0 1. Then binary number of 1 is 0 1 0 1 0 1 0. We will see about these in later on. The binary number of 10 is 1 0 1 1 1 1 0 1 0 1. Then we will also pronounce the binary number base 2. Another we will also say that another name of binary is base 2. Now we will see about the decimal number. What is a decimal number? How many digits are included in decimal number? Basically, in a decimal number, the total digits are included 10, but the number of digits from 0 to 9, the digit 10 is not included in decimal number. Keep in mind, otherwise your question will be wrong. So let us discuss the main points of decimal number. So the number that we are using to use to see are called decimal number. Yeah, decimal number consists of the digit from 0 to 9. I also say about the number of digits included in decimal number from 0 to 9. So let us discuss the example of decimal number. The the decimal number of 3 is 76. The decimal number of 15 is 324 23 234. So we will also pronounce decimal number is base 10. Now in this slide we will see the how binary and decimal number are equal to each other. So every binary number has a corresponding decimal value. So basically in this slide we will learn how a decimal number is equivalent to binary number, and binary number is equivalent to decimal. Let us discuss the some examples. The first one is the binary number of 1 in binary and decimal are almost same. 1 1. The binary number of the decimal number of binary 10 in a binary number is 2. In this slide we will see about the values of binary number. So let us discuss in a detailed way. Even though they look exactly the same, the value of the binary number 101 is different from the value of the decimal number of 101. The value of the binary number 101 is equal to the decimal number 5. The value of the decimal number 101 is equal to 101. When you see the number that consists of only 1 and zeros, you must be told if it is a binary number or as a decimal number. We all know that computers store information using binary number. Basically, computer has its own language. It store its information in the language of zeros and one. So that's why we said that computers store information by using a binary number. So in this slide we will study in a detail way how all information on computer is stored as a number. So let us discuss in a detailed way. All information that is processed by computer is converted in one way or another into a sequence of number. This included numerical information, textual information or picture. We will see later how text and picture can be converted into simple number. For now, just take our words for it. Therefore, if we can derive a way to store and retrieve numbers electronically, this method can be used by computer to store any retrieve and type of information. So in the previous slides we were study about the basic concept of binary and decimal. What is a binary number, what is a decimal number, how it is interconverted to each other, what is the relationship between decimal and a binary number. So uh, onward we will study about the conversion of decimal into the binary. Basically there are a lot of method to convert decimal into the binary, but we will study about the main and steps how to convert decimal into a binary. So let us discuss the first method, then we will see about the another method, or so on. So first of all we will see about the first method, how we convert decimal into a binary number. So let us discuss the examples. First of all we will see how 16 is converted into a binary number from decimal. So first of all we will see the question, then we will see about how we solve it in a binary number. To convert the decimal number to 16 to a binary, you will need at least 5 bits. What is a bits? We were study in a previous slides about the column, how we will convert, how we will see the bits. With 4 bits you can only store a number up to 15 bits, but with the 5 bit you can store number up to 31. So that's why we convert the decimal number of 16 into binary number into 31 by using of bits. So let us discuss another example. To convert the decimal number 106 to a binary, you will need at least 7 bits. With the 6 bits you can only store number up to 63, but with the 7 bits you can add up store a number up to 1 to 7. So that's how you convert decimal into a binary number by using a bits. So in this slide we will see how we convert 37 into a binary number from decimal in a quite easy way. We will see a different method how we convert 37 in a binary number from a decimal. So let us discuss some example. First of all we convert 37 into a binary number from decimal in from one method. So we will write uh, some number. 1 multiplied by 2 is equal to 2, then 2 multiplied by 2 is equal to 4, then 4 multiplied by 2 into 8, 8 multiplied by 2 equal to 16, 16 multiplied by 2 32, 32 multiplied by 2 is equal to 64, 64 multiplied by 2 128. So So let us discuss how we will solve this example in a simple way. So 1 to 8 is not fit into 37, because we will choose a number that is nearer to 37 and lower than 37. So 1 to 8 is a quite higher and higher number than 37, so that's why we can't choose that number. Same like 64 is quite higher than 37, that's why we can't choose 64. Then when we see what come next, 32. So the 32 two is fixed into 37 because it is nearer and lower than and then 37. So what we so then we subtract 37 into 32, come 5, continue the process with 5. So 16 doesn't fit into 15, so what we so then we minus a. So what will we do next? Then we choose a number 4. Why we choose a number 4? Because 4 is nearer and lower than 5. So what will we do next? Then we subtract 4 from 5, then comes answer 1. Continue the process with 1. 2 doesn't fit into 1, so what will we do next? Then we fit 1 into 1. So how we will convert 37 into a binary number? So the number that is missing in converting of 37 into binary from decimal, we replace them as a 00. So what is the answer comes? 001000101. Why we choose 00 left side? Because 1 to 8 and 64 doesn't fit in 37 converted into a binary number, because 1 to 8 and 64 are quite higher number than 37, so it's doesn't fit in 37. So that's why we we replace them as a zeros, double zeros. So there is another method how we convert 37 to a binary number. This method is almost used in everywhere in our schools, colleges, and universities. So we will see how we convert decimal into a binary number by using this method. This method is quite easier than previous method that we were discussed in previous slides. So let us discuss, and we will choose the same number 37. First of all, what we will do, we will divide 37 by 2. Why we divide by 2? Because we convert decimal number into a binary. That's why we divide that number by 2. First of all, if we divide 37 by 2, here comes 18 and one reminder. Then we again divide 18 by 2, answer comes 9, the remainder become a 0. Then we again divide 9 by 2, the remainder become 1. Then we again divide 4 by 2, the answer becomes 0 and remainder become 0. Then we again divide 2 by 2, the answer becomes 1 and remainder becomes 0. Remainder becomes 0. Then we again divide 1 by 2, the answer becomes 0 and remainder become 1. So how we will write the answer? We will always write answer from bottom to top. So write a reminder from bottom to bottom up and paired with learning 0 to full all 8 bits. Okay, so let us write answer. So first of all, what comes? 0, then then 0, then 1, and 00 101. So why we write 00 left side? Because we will always write answer in 8 bits. That's why we will choose 00 left side to complete the answer in 8 bits. So here is the another example how we convert 259 into a binary number using the same method that we discussed in the previous slides. So let us discuss in a detailed way. First of all, we will divide 259 by 2. So come answer 129 and remainder 1. Then we again divide 129 by 2. Answer becomes 64 and remainder 1. Then again we divide 64 by 2. Here answer become 32 and remainder become a 0. Again we divide 32 with 16 by 2. Sorry, answer becomes 16 and remainder become a 0. Again we divide 16 by 2. Answer become 8 and remainder become a 0. Again we divide 8 by 2. The answer become 4 and remainder become a 0. Again we divide 4 by 2. Answer becomes 0, remainder becomes 0. Again we divide 2 by 2. Answer become 1, remainder become 0. Again we divide 1 by 2. Answer become 0, remainder become 1. So how we write answer? We always write answer from bottom to top. Let us write the answer 0 0 0 0 0 0 0 1. 2 bytes are needed to store this number because we always completed the answer in 8 bits. So let us discuss two more examples so that we have a great command on this method, because this method is quite easier and everywhere this method is used. So in this example we will see how we convert 116 into a binary number from a decimal. So let us discuss. First of all, we will divide 160 by with 2. The answer become 18, remainder become a 0. Again we divide 80 with 2. Answer become 40, remainder becomes 0. Again we divide 40 with 2. The answer becomes 0. Answer become 20, remainder becomes 0. Again we divide 20 with 2. Answer become 10, remainder become 0. Again we divide 10 with 2. Answer become 5, remainder become 0. Again we divide 2 with 5. Answer become 2, remainder become 1. Again we divide 2 by 2. Answer become 1, 0, remainder becomes 0. Again we divide 1 by 2. Answer becomes 0 and remainder become 1. So how we write answer? Always write answer from bottom to top. So let us write answer 1 0 1 0 0 0 0 0 and base 2. Let us discuss one more example by this method. So in this method we convert 47 into a binary number by using a decimal number. So first of all we will divide 47 by 2. The answer become 23. Again we divide 23 by 2. Answer become 14, remainder become 1. Again we divide by 2. Answer become 5, remainder become 1. Again we divide by 2. Answer become 2, remainder become 1. Again we divide by 2. Answer become 1, remainder becomes 0. Again we divide by 2. Answer become 0, remainder become 1. So right answer. How we will write answer? Always write answer from bottom to top. 101111 base power 2. So in this slide we will see the first method that we were study in the previous slides in a detailed way with the examples and the picture. So from that method we will convert 18 into a binary number by using a decimal number. So first of all we will write two horizontal columns and some horizontal columns as well. So first of all what we will do, first of all we will multiply 1 by 2, answer become 2, then again 2 by 2, answer become 4, then 4 multiply by 2 8, 8 multiply by 2 16, 16 multiply by 32, 16 multiply by 2, answer become 32, 32 multiply by 2, answer become 64, 64 multiply by 2, answer become 128, 128 multiply by 2, answer become 256. So in this example we will convert 18 into a binary number by using a the decimal number. So first of all what we will do, first of all see the number that's nearer to the 18 and lower than, and that digit is lower than 18. So 256 is a quite higher number than 18, same like 128 is quite higher, same like 64, same like 32. Then 16 is nearer to 18 and lower digit than 18, so we will choose 16, write 1 and in lower column of 16, then divide 18 with 18 by subtract 18 from 16 from 18, answer become 2. Then see where which digit is near than 2. So 8 is quite higher than 2, so we can't choose that number. Again see the 4 is also higher digit than 2, so we can't choose that number. Then again we choose 2 because 2 is nearer and equal number. So write 1 bottom of 2, so answer become so subtract 2 from 2, answer become 0. So write a so what we'll do next, write a double zero in the side of 8 and 4. So write a 000 and also 0 in the bottom of 1. So here is the answer 10010 in base power 2. Another example you see in the bottom of this slide 28, the same like how we convert 28 into a binary number by using this method. So here we end up today's presentation. Thank you, take care, goodbye.